Okay guys, in this video we're talking about solving systems of equations by graphing. So again, like we talked about, we probably did elimination and substitution already. You probably went through that. Now we're going to try to figure out how do we solve systems of equations. So two lines, right? Two linear equations. How do we solve them by graphing? So if we graph the two equations, how do we find the solution? So if you remember the solution, and this is the purpose right here, the solution is where the two lines cross. So if we graph the two lines and we figure out where they cross, which point they cross in, that therefore is our solution by definition. So let's start with example number one. Let's say I want to graph one of the lines and I'm going to be fancy and I'm going to use color here. So y is equal to x. Again, if I want to graph this, I want to make sure it's y equals mx plus b, right? There's a number in front of the x that they don't write because they're lazy, but there's a 1 there. And there's a number over here that they don't write because they're lazy, but there's a 0 there, right? So this is actually y equals 1x plus 0. So if I wanted to graph this, I would start at the 0, and my slope would be up 1 over 1. So up 1 over 1. If you want to be more precise and then make this line as straight as possible, you would just do it over and over again. So I'm going to go again up 1 over 1, up 1 over 1, up 1 over 1. And so I can make the straightest line that I can. So if I connect the dots, then this will be my line. So there we go, done. So one of the lines is graphed. So start with the y-intercept, which is the one without the x, and then the one in front of the x is the rise over 1 or the slope. Let's do the other one. So now if I want to graph y is equal to negative 3x plus 4, we've probably done graphing before, so I'm going to go ahead and jump right into it. The number in front of the x is negative 3, and then I'm going to put that over 1 because I need a slope for this, right? The starting point is 4, so up 1, 2, 3, 4. My slope is down 3 over 1 because it's negative. So now I have to go down, starting at the starting point, 1, 2, 3 to the right 1. So it overlaps with this point. And then I do it again, down 3 over 1. So down 1, 2, 3 over 1. So now I have another point. And then I can do it again, down 1, 2, 3 over 1, etc. Now if I connect those points that I created, then I get my second line, which I highlighted in blue. So this is going to be the blue line right here. And then the point where they cross, this is our solution to the system. So this is a solution. So all you have to do is figure out what is the solution, right? So where do they cross? This point is 1, 1. So x is equal to 1, y is equal to 1. Because if you graph that point, it crosses at 1, 1. Cool. Okay, so I hope you guys got that. That's basically it. So the only other examples that I have for you is the situations in which the y is not by itself. And that's all you have to do for that is get the y by itself yourself. So let's do that separately. So let's say we have another set of lines right here. So this line right here, I'm going to just go ahead and do some work for it on this side. So that line is going to be 3x minus 2y is equal to 6. Now, I can't graph this yet. I have to get the y by itself. So I will put a little box around the y, draw the wall, and then move everything to the other side. So starting with the one that's furthest away from the variable, which in this case is y. So starting with the x. So the 3x and the negative 3x cancel out. You get negative 2y is equal to negative 3x plus 6. Again, we're not combining these two. This is not 9x. This is not 3, whatever. You're just rewriting it. So stays negative 3x, stays 6. You're just writing it longways. Now we have to get rid of the negative 2, so we're going to divide this side by negative 2. That will go away. Divide this side by negative 2. Everything is divided by the negative 2. Therefore, this is going to be divided by the negative 2, which it doesn't really go into it. So we're going to leave it as a fraction, as positive 3 over 2x. The negative and the negative canceled. And then this 6 is divided by negative 2 as well. That actually goes into it nicely. It's going to give you a negative 3. So the green highlighted equation that I highlighted in green initially actually comes out to be this. Y is equal to 3 over 2x minus 3. So now we can graph it, right? So now if I wanted to graph this, I would start at the negative 3. So 1, 2, 3 down here. And then I got to go up 3 over 2. So 1, 2, 3 up to the right 2. 1, 2, 3 up to the right 2. And then connect the dots and you will have your first line. Now, we don't know the solution yet because we don't know what the other line looks like or where it crosses this one. So we have to do another set of simplification for the other part. So now let's do some work to get the y by itself for the other line. So now for this one, I have the equation x plus y is equal to 2. Again, we got to get the y by itself. So we draw the wall. We're going to subtract x on both sides, minus x, and we're done, right? Because the y is alone. Great. So we get negative x plus 2. Now, I started at 2, and then the number that's in front of the x would be a negative 1, so I can write it as negative 1 over 1. So now that I have the y by itself, I can graph this. So let's do that. We're going to start at 2 on the same graph. We're going to go down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, etc., etc. And then the point where they cross is going to be our solution to the system. So in this case, the blue line and the green line connect at one single point, right? And that single point would be right there, which is considered the solution. And that solution, if you graph that point, it's 2 to the right, and then we don't go up or down. So it's actually 2, 0. So x is equal to 2, y is equal to 0 would be our solution. Cool? All right, the only thing that I want to mention before I stop talking about graphing equations with the method of substitution, elimination, or graphing in this case, is some special cases when it comes to graphing. And those special cases are, well, I mentioned it in one of the videos earlier, but let's just go over it. So let's say we wanted to graph this, right? So I'm going to go ahead and do what I did in the last problem. I'm going to make this, I'm going to do some work here for that one to get the y by itself. And we're going to do some work here for the other one to get the y by itself, which we did in the last problem. So no big deal. I'm going to go a little bit faster this time. So 2x minus y is equal to 1. Draw the wall. Subtract 2x. We get this to go away. Negative y is equal to negative 2x plus 1, because that's positive. Then we're going to divide by negative 1. Divide by negative 1. Divide by negative 1. We get equation y is equal to, the negative and the negative cancel, so we're just left with 2x. Positive divided